Okay, so today we're doing 9.6, and it is going to use those properties that we learned in 9.5 on Wednesday to solve exponential and logarithmic equations. Now, depending how the equation is given to you is what method you're going to use. These first couple of problems, the x that you're solving for is in the exponent. So there you have two options here. So let's look at one like number one. You have 3 to the x equals 243. Your first option and the easiest option is if you can rewrite this right side as a base of 3 to a certain power, then you can just simply set your exponents equal. So if you can make these two bases be the same thing. So in other words, is 243 3 to a certain power? Let's look and see what I'm talking about. So let's say 3 to the 4th power. Let's see what that would be. That'd be 81, which means it would need to be higher than 3 to the 4th. So if you try 3 to the 5th, it gives you 243. So that means I can rewrite this right side. Instead of 243, I can write it as 3 to the 5th power. Still have 3 to the x here. Which means if my bases are the same, all I have to do to solve for this x is make this exponent equal to that one, which is just x equals 5. So the best way and the easiest and simplest way is if you can rewrite both of your sides to be the same base, because if that's the case, then you just make your exponents equal to each other and solve it. Okay, this wouldn't even have, once you made your exponents equal to each other, there wasn't even any solving to do. Okay, let's look at one like number 2. You have 4 to the 4x equals 64. So can you rewrite 64 as a base of 4 to a certain power? Let's see, 4 squared is 16, but 4 to the 3rd power is 64. So I'm just going to rewrite this side. Instead of 64, I'm going to write it as 4 to the 3rd power. So over here, just bring down this 4 to the 4x. So once again, if your bases are the same, then you just set up an equation that puts your exponents as being the same. So 4x equals 3. This one I did have a little bit of work to do. I just need to divide both sides by 4. So x equals 3/4. But when we get to number 3, we're not going to have this case where you can rewrite the right side to have the same base as the left. So that's when we're going to have a different method. Now remember, there is a property of logarithms that if you have an exponent of your logarithm, what did that property tell me I could do? For instance, if I had this right here, remember what that log property says is if you have an exponent of your logarithm, it can be rewritten by bringing that exponent down in front of your logarithm and having it be 5 times log base 10 of 3. Again, that's what we did in section 9.5. We are going to use this property now because sometimes our x is in the exponent that we need to solve for, and you can't isolate an x if it's in the exponent. But if you bring it down here, then you can isolate it. So let's look at number 3. You've got 2 to the x equals 19. So again, the x that I'm solving for is in the exponent. I can't use the method that I was using in the first 2 problems because I can't rewrite 19 as a base of 2. So now I've got to use that method that says I can bring my x out of the exponent as long as I put it in front of the log. Well, I don't see a log, but what is the rules of any equation say I can do? I can do absolutely anything in the world to one side of an equation as long as I do the same exact thing to the other side of the equation. So I'm just going to log both sides. So I will just log 2 to the x. If I log this side, I'll have to log this side. So again, I've just logged both sides. Now I can use that property of logarithms that says I can bring that x down in front of the log. So now I have x log 2 equals log 19. So if I want to isolate this x now, I can, because what does this say? X times log 2. So that just means to get rid of all this so the x will be by itself, I'll just divide by log 2. If I do it to one side, I got to do it to the other. Cancel, cancel. There's my x by itself. This is calculator work. So log 19. So just the log button. 19, close, divided by log 2, close. Enter, round it to 4 decimals. So 1, 2, 3, 4. When I go after the 9, it's a 2, which means I don't need to round the 9 up. So just 4.2479. Right? Number 4. I have 2 to the 6x minus 1 equals 16. So remember, the first thing you're going to do, because it's easier if you can do it, is check this side. Can I rewrite this side as a base of 2? I can't. What is 2 to the 4th power? 2 times 2 is 4, times 2 is 8, times 2 is 16. So I can rewrite this 16 as 2 to the 4th power. So I don't have to use the log on both sides. You can. It will work. You just don't have to. Because I can rewrite this side to have the same base as the left. If they're the same bases, then just set up their exponents to equal each other. So 6x minus 1 equals 4. And solve for x. So add 1 to both sides. So 6x equals 5. And divide by 6. So x equals 5, 6. Sorry, I get my coffee. All right, number 5. Two to the x equals 6. So let's see, I cannot rewrite 2 with a base of, saying it backwards. I cannot rewrite this 6 as a base of 2, right? 6, I can't say 2 to the 2nd power or 3rd power. It skips right over 6. So I am going to use that log method because my x is in the exponent. In order to get it out of the exponent, I need to log both sides. So log of 2 to the x. If I log the left, I need to log the right. So log 6. Now, bring your x out of the exponent. So x log 2 equals log 6. Get the x by itself since this is times. I'll just get rid of that log 2 by dividing by log 2. So x equals, do this division. Just do it in your calculator. So log 6, close, divided by log 2, close. So again, enter, round it to 4 decimal places. So 5, 8, 4, 9. After the 9 is a 6, which means the 9 does round up to 10, which means this 49 actually rounds up to 50. So 2.5850. Okay, now I'm actually going to not do number 6. I took that out of the homework. There's something we just don't need to go there. So I'm going to go to number 7. So I have E. Oh, wait, let me talk about something. I see this is what's going to come up here. Remember that property of logs that says log base 6 of 6 to the 5th power, that says if your base and this number are the same, that is going to be equal to whatever that exponent is, right? Because 6 to the 5th power is equal to 6 to the 5th power. So that's why if these two things are the same, log, your base, and what you're taking the log of is the same thing, it is simply equal to whatever that exponent is. So let's remember that when we go on number 7. I have E to the T equals 629. Okay, now before I get started, let's remember something else. When I'm dealing with what is ln equal to, the natural log really is just log base E. Okay, so I'm just kind of reminding you of things that we have learned earlier in this chapter that we're going to use to help us solve these equations. So again, remember the natural log, or ln, is just simply log of base E. Okay, so let's remember that. Because if I'm dealing, so here's my t that I'm solving for, which means I need it to come out of the exponent. The way I get it to come out of the exponent is I'm going to log both sides, but instead of regular log, I'm going to natural log both sides. Since I'm dealing with an e, I can do anything to one side as long as I do it to the other. So I'm just going to ln both sides. So ln e to the t power. If I ln this side, I have to ln this side. So now the t can come out. So I have t times ln e equals ln of 629. Now I can, to get this t by itself, divide both sides by ln e. But remember, what is ln? That is log base e. So if I have log base e of e to the first power, anytime you see ln of e, it is equal to 1. Because if I rewrote this as log base e, right, that's what natural log is, of e, these two things are the same, which means all of this is equal to what this exponent is, and it's 1. So ln of e is equal to 1. So this really just says t times 1, or in other words, just t. So anytime you see ln e, it is just simple to just turn it into a 1. Now, the other side, I still have ln of 629, but the t is isolated, so all I need to put in my calculator is ln 629. And again, there's an ln button on your calculator. Type in 629. Close it. Enter. There's your decimal, round it 1, 2, 3, 4. After the 1 is a 3, so I don't need to round it up. So 6.4441. Okay, let's look at number 8. the negative 0.15t equals 0.43. So again, I'm solving for this t that's up in the exponent. The only way I can get it down in front of and not in the exponent is to log both sides. And instead of logging both sides this time, since it's an e, I'm going to ln both sides. So let's see, I'll have ln e to the negative 0.15t equals, if I ln this side, I have to ln this side. ln 0.43. So now I can bring that whole thing out of the exponent. So now I have negative 0.15t times ln e equals ln of 0.43. So once again, I see an ln e, which means that is just, anytime I see it, I can just turn it into 1. So I really just have negative 0.15t equals ln of 0.43. So I'm isolating t. So what do I need to do to both sides? I just need to get rid of this negative 0.15. So I'll just divide both sides by it to cancel it. So here's my t by itself. Calculator work. ln 0.43. 0.43. Close, divided by negative 0.15. So again, just type that exactly in your calculator. Hit enter, round it 1, 2, 3, 4. After the 4 is a 6, so I will round that up to a 5. So 5.6265. All right, number 9. We've got a lot of work. I'm trying to squeeze it all in on this board. So I have 15 to the x equals 5 to the x plus 2. Oh, it's up there in that glare. So again, I am going to log both sides. I have x's in both of my exponents. That's what makes this one a little bit more work. But again, I can't start solving until I get my x's down on the regular level of the rest of the equation and not up in the exponent. So I'm going to log both sides. So log 15 to the x equals log of 5 to the x plus 2. So now I can bring the exponents down. So on the left, I have x log 15. On the right side, I bring this whole exponent down. So x plus 2 log 5. Now here's where some more work happens. This x goes to log 5, and so does 2 go to log 5. So I need to remove those parentheses. So it's this right here. It's like you're distributing that log 5. So let's see, x log 5 plus 2 log 5. I'm just going to drop this left side down. X log 15. So let's get to let's think about this. I'm trying to solve for x, right? X needs to be isolated. I see x's on both sides of my equal sign. So I want both of the terms that have an x to be together on one side of my equal sign to see how I'm going to be able to isolate that. So I'm going to move this x term over here to be on the same side as this x term by just subtracting x log 5 from both sides. So now, it'll cancel it on the right. On the left, I'm just going to have this x log 15 minus x log 5. So again, these are just two separate terms. Since they're not like terms, one's log 15, one's log 5, I can't put them together. On the right, all I have left is 2 log 5. So now, I have x's in both terms on the left, which means it's a common factor. I can pull out the x, right? I'm trying to isolate x. So what I'm going to do is just think of it as the greatest common factor of both of these terms and pull it out. And put in parentheses what is left. If you pull the x out, I'll be left with log 15 here. Minus, I pulled the x out of this term, so I just have log 5. Over here, I have 2 log 5. So to isolate this x, what do I need to do? Now, since it's x times all this, I'm just going to divide by this whole thing. Divide by log 15 minus log 5 to cancel all that out, which will mean x will be by itself. If I do this side, I also have to do the other side. So let's see, I'm dividing this side by the same thing I divided this side by, which is log 15 minus log 5. So now, if I do this calculator work, that will give me my answer. Now, you'll have to be careful with this calculator work. You're going to have to do some parentheses work in the bottom. So let's see. In the top, I have 2 log 5. Close. Then divided by, now in the denominator, I need to put parentheses around this to make it all be in the denominator of that fraction. So do an open parentheses. Then when you type in log 15, you're going to have to close the parenthesis around that 15, right? So close it. Then minus log 5. So you're going to have to close the parenthesis around the 5 and another closed parenthesis to close this parenthesis. So again, it puts parentheses around the 15 and the 5. So over on that right side, you need 2 closed parentheses. And then hit enter. So now round it to 4, 2.9299. And since that's a 4, I don't need to round that 9 up. So 2.9299. So again, if you don't put parentheses around that denominator, once you hit this minus, you're kind of telling the calculator to put that next thing not in the denominator, over to the side. So open log 15, close, minus log 5, close, close. Okay, now on the next page, here we're going to be solving, so those are exponential equations, right? Because the x that we're solving for was in the exponent. Now, look at log equations. There's several different methods here depending on what you're given. I have log base 6 of x equals 2. actually going to rewrite this as an exponential equation because remember, this number right here is whatever the base raised to that power is equal to that. So I have 6 to the second power is going to equal that x. Well, what is 6 to the second power? It's just 36. So if you just have one log in your equation, rewrite it as an exponent. Do whatever this base is, raise it to that power, and then make it equal to whatever is here. Okay, same on number 11. I have log x equals -1. So again, I just have one log, which means I need to write this base to this power and make it equal to that x. If you have a log and you don't see a base, remember, it is automatically base 10. So I will have 10 to the -1 power is going to be equal to whatever is right there, which is your unknown x. So now I'll have to figure out is what 10 to the -1 is, and I can just type that in my calculator. 10, go up into your exponent, type in -1 to your exponent, and it will tell you 0.1 equals x, or 1/10. All right, number 12. Log base 5 of 4x minus 4 is equal to 4. Same method, right? I just have one logarithm in my problem, which means I can use its base, raise it to the 4th power, and make it equal to 4x minus 4. So 5 to the 4th power is equal to 4x minus 4. So now here's my x that I'm solving for. I just need to solve this equation. 5 to the 4th power is 625. 5 raise it to the 4th is 625 equals 4x minus 4. If I'm solving for x, I need to add the 4 to both sides. $625 plus 4 gives me $629 equals 4x. Solving for x, so I'll just divide by 4. So x equals 629 over 4, and for some reason in the answer sheet it writes this as a decimal answer. It should take 629 over 4. I don't know why it wouldn't, but if it does make you write it as a decimal, then just do the 629 and divide it by 4 and write it as a decimal, which just gives you 157.25. Okay, before we do 13 through the rest, let's remind ourselves sometimes I have not just one logarithm. I may have 2 logs on the same side that have the same base that are either added or subtracted. Let's remind ourselves what these properties, the properties that can help us solve these equations. So remember in 9.5, if we had two logs that had the same base that were added together, And I was asked to write this as a single logarithm, which is what you want to see. You want to see a single logarithm. You don't want to see two logs on the same side of the equal sign. If they have the same base, remember, you could rewrite this as a single logarithm. What does adding two logs turn into? The single logarithm, which is log base 5, then multiply these together, which would be x plus 2. So again, if you have the sum of two logs that have the same base, you can rewrite that as a single logarithm of that base and multiply those together. We also learned another property that said, okay, I'll just use the same number. Say I had log base 5 of x minus log base 5 of x plus 2. And I needed to rewrite that as a single logarithm. If it is subtraction, you could rewrite this as a single logarithm, log base 5. Subtraction turns into division when you're rewriting as a single. This over this. So log base 5 of x over x plus 2. So again, addition turns into a single logarithm by just multiplying those together. Subtraction turns into a single logarithm with this one over that one. So we're going to use those properties when we have multiple logs on one side of the equal sign. Like number 13, you've got log x plus log x plus 48. Equals 2. So I have 2 log, they're actually base 10, right? So they have the same base. I just don't see the base because it's base 10, which means I can rewrite this as a single logarithm, because if I have a single logarithm, I can use the same method I was doing on the last couple of problems by raising the base to 2 and make it equal to what the log is. So I have log. Since it's adding, that means I need to rewrite it with these multiplied. So x times x plus 48 equals 2. So now I'm back to the method I've been using. I need to raise the base, which is 10, to the second power and make it equal to all that. So I'll write that. So 10 to the second power is equal to x times x plus 48. Let's remove these parentheses by distributing this x and rewriting 10 squared as 100. So 100 equals x times x is x squared plus x times 48 is 48x. Now we've got something new here. We're solving quad, right? X squared means quad, which means I need to get all my terms on one side. And then I have a couple options. I can either factor it and set my factors equal to 0, or where can you always take quads to be solved? Your quad program of your calculator. So let's see. The first thing I need to do is subtract 100. So now I have 0 equals x squared plus 48x minus 100. Again, I can go straight to quad, get my 2 answers. If not, I can factor this. It's not bad. X and x for x squared. Factors of negative 100 that add to positive 48 would be a positive 50 and a negative 2. If I set those equal to 0 and solved them, I would get, this would turn into a negative 50. This would turn into a positive 2. Now, look at your 2 answers and remember what your x is. If I put a negative 50 in here, remember what happened when you typed in your calculator, log, and then put a negative here. It would tell you a non-real answer. So when you get these, if you have an x here and it's a log and it's a negative answer, that's a non-real answer. You're just using your positive answer. So just positive 2. All right, 14. Log base 4 of c plus 16 minus log base 4 of c plus 7 equals log base 4 of c. So again, look at the left side. I can clean that up by rewriting this minus of 2 logs base 4s, turning it into a single logarithm. When I turn it into a single logarithm, since it's minus, I'm going to have the c plus 16 over the c plus 7. So let's see, I have log base 4, put one over the other. So c plus 16 over c plus 7 equals log base 4 of c. So now look what we have. I have log base 4 actually on both sides, which means I can divide. I can do anything to one side as long as I do it to the other. What if I just divide log base 4 off of both sides? So this one cancels that. That one cancels that. So all I'm left with on the left side is c plus 16 over c plus 7. On the right side, I have just a c. Sorry, my kid's school just called. So this right here, if I'm solving for c and I have a c in the denominator, I need to cancel this c plus 7 out. I don't like to see fractions with a variable in the denominator. Well, I can just cancel that out by c plus 7, c plus 7. So this c plus 7 cancels that one. All I'm left with here is c plus 16 equals c squared plus 7c. So again, it's quad, which means I need to put both of these terms over on the right. So I'm going to subtract c and subtract 16. So on the left side, I have 0 equals c squared, 7c minus 1c is plus 6c. Bring down the minus 16 and either take that to your quad program, get your 2 answers, or factor. Let's see, c and c. Factors of negative 16 that add to positive 6. Let's see, that would be a positive 8 and a negative 2. But when you set them equal to 0 and solve them for c, that's going to turn to negative 8, and that'll turn to positive 2. The negative answer doesn't work, So you're just left with positive 2. Okay? All right, 15. 3 more. Log base 3 of x plus 1 minus log base 3 of x equals 3. Oh, sorry. So again, it's subtraction of 2 log base 3, so I can rewrite that as a single logarithm. So log base 3, I'll put this over that. So x plus 1 over x equals 3. So here I have 3. So now since I do just have this single logarithm, remember, I can do this base raised to that power is equal to that. So 3 to the 3rd power is equal to x plus 1 over x. So let's see, 3 to the 3rd is 27 equals x plus 1 over x. Remember, we don't like to see the variable in the denominator, so I'm just going to multiply both sides by that x. On the left, I have x times 27, which is 27x. These cancel. All I have left on the right is the x plus 1. And remember, you're just solving for x, so this time I don't even have an x squared. I'm just solving for x. So I will subtract x from both sides. So 27 minus 1 gives me 26x equals 1. And divide by 26. So x equals 1 over 26. All right, 2 more. Number 16. ln x plus ln x minus 1 equals ln 2. So these are both ln's. They're added. Oh, sorry, Lindsay. Since they're added, I can rewrite them as a single ln. Since they're added, I'm going to multiply these two. So x times x minus 1 equals ln 2. So I have ln's on both sides. So you might as well just divide them off, right? If you have the same log on both sides, just divide whatever that is off of both sides. Cancels here. Cancels here. I'll distribute this x. So now I have x squared minus x equals 2. Since it is squared again this time, it is quad, which means you need to set it equal to 0. So minus 2 from both sides. So x squared minus x minus 2 equals 0. Either put it in your quad or factor it to solve. X and x for x squared. Factors of negative 2 that add to negative 1 would be a negative 2 and a positive 1. And if I set those equal to 0, I would get positive 2, negative 1, and take off your negative answer. So positive 2. Last one. So again, if you have logs or ln's on both sides, divide them off. Log base 3 of x plus 4 plus log base 3 of x minus 4 equals 2. Since they're added, rewrite this as a single log base 3 and multiply the x plus 4 and x minus 4. So log base 3, x plus 4, x minus 4 equals 2. So I don't have logs on both sides this time. I just have it on the left, which means I use the method where I raise this base to that power and make it equal to all of this. So 3 to the second equals x plus 4, x minus 4. And solve it. 3 to the second gives me 9. I need to FOIL this, right? So x times x gives me x squared. My outside, x times negative 4 is negative 4x. My inside, positive 4x. And my last, positive 4 times negative 4 gives me negative 16. These middle two terms, when you combine them, cancel out, right? Because you've got negative 4x plus 4x. So let's see what I have left. I have 9 equals x squared minus 16. Again, it's quad. So get it all on one side. So subtract the 9 from both sides. So 0 equals x squared. That turns into minus 25. So again, it's quad, but be careful when you put that in your quad program, your A will be 1, right? Your B, since there is no x, your B will be 0, and your C will be negative 25. Or if you choose to factor it by hand, that's a difference of squares. X and x for x squared, 5 and 5. For 25, 1 plus, 1 minus. When you set those equal to 0, that one's going to give you negative 5, and that one will give you positive 5. Your negative answer is not right or not true, so positive 5. Okay? All right, so we actually only have 2 more sections to cover. We'll cover next week, which will be 9.7 and 10.2. And that'll be all of the new information for the whole semester. So the rest of the semester, which won't be that much longer after that, we'll be reviewing for test 4 and reviewing for the final. All right. Have a good weekend.
Miss Hanson.
Yeah.
Can you post the Wednesday's video on Blackboard too?